Hello everyone. In this video we will be discussing last chapter in module 5, that is about anti-friction bearings. So particularly the two major topics we will be discussing here, that is type of rolling contact bearings and their applications, and the static and dynamic load capacities. So already in the previous chapter of module 5 where we clearly discussed what is lubrication, the different types of the pressure distributions, the minimum and maximum oil film thickness. So all those things we have discussed, and very slightly we had discussion even on the bearings. So now here exclusively we will be studying about anti-friction bearings. So when I speak about the types of rolling contact bearings and their applications, so first we should able to understand what are the different roller contact bearings are available. Then it would be easy for us to understand its applications. First let us start with the first type, that is roller bearings. So roller bearings is also known as rolling element bearings, which are similar to all ball bearings in that they are designed to carry a load while minimizing friction. But however, rolling bearings transmits loads using cylinder rolling elements rather than balls to maintain the separation between moving parts of the bearing. So in some of the industrial machines where this is recommended, and bearings instead of going with the general solid bearings, here the roller bearings can be seen. And these versatile bearings can contain single or multiple rows of rolling elements, and multiple rows can significantly improve radial load capacity. Also, the use of different roller shapes can further reduce friction and both radial and axial loads. While roller bearings can handle higher loads than conventional ball bearings, their applications are generally limited to low speed operations. So many types of roller bearings are self-aligning and are easily able to overcome misalignment and mounting issues, cutting down on maintenance, repair and labor needs. So roller bearings come in a wide range of shapes and sizes and can be customized for specialized situations. Also, the use of the flanges, cages and multiple bearing rows can allow for higher performance to meet specific application needs. And roller bearing types and applications, if you see, there are thousands of different types of roller bearings available to meet specific application requirements. So Emerson Bearing offers a broad selection of roller bearings, including the following popular. So cylindrical roller bearings. So these bearings features rollers that are longer than their diameter and can tolerate higher loads than ball bearings. Our cylindrical roller bearings can carry heavy radial loads and are able to be used in high speed applications. Moving to the next type, spherical roller bearings. So this can carry heavy loads even when dealing with misalignment and shaft deflection. They can be designed to have cylindrical or tapered boards for mounting with or without a sleeve adapter, and available with various internal clearances and retainer options. And spherical roller bearings can handle axial loadings in either direction as well as heavy shock loads. So these bearings are available in bore dimensions ranging from 20 mm to 900 mm. And moving to the next type, needle roller bearings. This type of bearing is thinner than conventional roller bearings and can be designed with or without an inner ring. Needle roller bearings are ideal for dealing with radial space constraints in heavy load, high speed applications. Drawn cup styles allow for high load capacities and large grease reservoirs while still offering a slim cross section design. And these bearings are offered with inch or metric seals. And moving to the next type, taper roller bearings. These bearings can support radial and thrust loads. They can only handle unidirectional axial loads, so a second laterally reversed bearing is required for counterstay. And taper rolling bearings are available in inch and metric sizes, and roller bearings are used in a wide range of applications from heavy equipment and machinery to power generation, manufacturing and aerospace. And here we could able to see a small example of taper rolling bearings. And this is the symbols we supposed to denote, where D the diameter, that is outer diameter, and C we can able to see the width, and FW is nothing but the radial force. And moving to the next concept which we supposed to discuss in this video, that is the static and dynamic load carrying capacity. As we are aware, like when we are speaking about the shafts, two loads comes into the picture, that is static and dynamic load. And until and unless we clearly understand what is the major difference between the static and dynamic load, we can't able to understand the concepts, and even problems also we can't able to solve it. So generally we know like the static load and dynamic load, where gradually we will be applying the load starting from a minimum value, and whatever the load which we supposed to apply, till then we need to apply the load. But in case of the dynamic load, where in the motion we could able to drastically increase or decrease the load what we are applying. So this difference we should keep in our mind, so that it will be easy for us to understand the concept. And rolling element linear bearings such as the round shafts and bushings, profiled rail guides, crossed roller slides, and even ball screws have two load capacity specifications, dynamic load capacity and static load capacity, which are based on different operating parameters and performance criteria, which are completely independent of each other. So to accurately size and select a rolling element, a linear bearing or ball screw, it's essential to understand the differences between them and when each one is used. And here we can able to see the differences between the static and the dynamic of the same setup. We could able to see this, and how it is performed also in many like animation video we could able to understand it. And moving to the next one, the dynamic load capacity, which is usually denoted as small c, is based on empirical testing, in which a load that is constant in magnitude and normal to the load bearing surfaces allows the bearing to achieve a defined travel distance, that is a linear guide or number of revolutions. We can call it as a ball screw without fatigue. And fatigue is defined as the presence of flaking on the surface of the rolling elements or the raceways. The dynamic load capacity is used to determine the rated life of a rolling element bearing, and this life is commonly referred to as the L10 life, because it is the life that 90% of a group of identical bearings is expected to achieve under set conditions of load and speed. And for the linear bearings that use balls, for L10 formula, which is equal to C by F power 3 into 1 lakh meter. For linear bearings that use rollers, so L10 is equal to C by F power 10 by 3 into 1 lakh meter. So where L10 is nothing but calculated or rated life of the bearing, and the capital C is the nothing but basic dynamic load capacity, and F is nothing but applied load. And dynamic load capacity and L10 life calculations are defined by the ISO 147281 standard for linear bearings and by the ISO 34085 standard for ball screws. The ball screw standard specifies that dynamic load capacity is based on L10 life of 1 million revolutions. However, the linear bearing standard allows the dynamic load capacity to be specified for an L10 life of either 50,000 meter or 1 lakh meter. The basis of L10 life for linear bearings is important to note, especially when comparing linear guides from different manufacturers or even of different series from the same manufacturer. If a linear guide whose dynamic load capacity is based on 1 lakh meter is being compared to a linear guide whose dynamic load capacity is based on 50,000 meter, one of the following conversation should be applied. That is, divide the 50,000 meter load capacity by 1.26 or multiply the 1 lakh meter load capacity by 1.26. It explains how the 1.26 conversion factor is derived. And static and dynamic load carrying capacity weight. A static load capacity CO is the amount of load a bearing can withstand before the sum of the ball and raceway deformation equals 0.01% of 0.0001 times the ball diameter as defined by ISO 147282. And static load capacity is almost always higher than dynamic load capacity because its limitation is the plastic deformation of the ball and raceway material, which occurs when the load is applied to the bearing in a static, non-moving or slow moving state. And here we could able to see the clear information in the sketch. And we can continue the remaining things in the next video. Thank you.